All right, this is 610A, model and solve one variable, one-step equations that represent problems including geometric concepts. This one's pretty straightforward. They have to be able to match a model to an equation, and they have to be able to solve a one-step equation. And the geometric concepts comes in with perimeter, area, and volume. So the student SE, they're going to be expected to solve one-step equations and be able to identify a model that represents the situation. So we're going to start with modeling equations. All right. In order to solve an equation word problem, you can always create a model to help. Take a look at the picture below and discuss with your class how this model was set up using the information from the word problem. I would leave this on my board and read the problem to the students and then have them discuss in their groups where the numbers came from and how they set that model up. Okay, so the example is Abigail got paid $30 to mow her parents' lawn. She needs $3.99 for a new book and $7.50 for a ticket to the movie she wants to go to with her friends. Write and solve an equation to show how much money Abigail has left. Now, they're used to doing these sort of problems. They're just not so familiar with having to draw a model to represent it. So I don't think solving these is going to be the issue. It's going to be them trying to figure out which model is appropriate. So as you can see, the 30 is the amount of money that she has, so that's going to take up the entire space. These smaller boxes are going to be the amount of money that she has used. And actually that $6.50 is wrong. That should be $7.50 because that's what it says in the problem. So that should be a $7.50. And they just need to understand that the way that they solve this is still the same. They just need to be able to relate it to a model. Now, on this next page, the YouTube video, I'll bring it up for just a second, but the YouTube video is actually someone showing them how to use a model to set up the equation. So it's a very good video. And you could even put this one on Schoology for them to go back and watch on their own if you wanted, or you could show it whole class. All right, so after that, then we come to the page where they have to match the model to the problem. I would still do this whole class, and I would talk about each problem with the class. So I would read the first problem and then have them in their groups see if they can figure out which model it might be. And then also in their groups, have them explain why they think that. Why did they use that particular model for that particular problem? What words gave them a clue as to what model it was? Anything to get them to dig a little deeper so that learning is etched in there, and the next time they see it, they'll be able to retrieve it easily. Now, this is going to be without the model. So solving one-step equations, I would have these steps printed and put into their notebooks. So every time we're solving equations, they can get out their notebook and have it on their desk so that they can refer to it. There's always going to be a variable, and we're wanting them to circle it so that they can isolate it. And we need to talk about this word isolate because a lot of our students are not familiar with it. So they need to understand that to isolate means to get it by itself. All right, and then we're going to talk about the operation being used and the identity of the inverse operation. Well, we've talked about the different properties, and they know the inverse property. So the inverse of addition would be subtraction. So now that's the first question that I would ask my kids. Okay, so if we're adding, how do I undo addition? What is the inverse of addition? And they should know that the inverse is subtraction. These kinds of problems are all about opposites and doing the opposite of what the problem is telling us. So we're going to solve by using the inverse operation on both sides. I also tell them that this is like a seesaw. Whatever I do to one side, or like a balance, whatever I do to one side, I have to do to the other. Otherwise, I'm going to tip the scales and one side's going to be higher than the other. All right, then I create a zero pair to cancel. So the opposite of 3 is negative 3. So that 3 plus negative 3 equals 0. So then I'm just left with x. And then I have 8 minus 3, which equals 5. So 5 would be my solution. And this is a pretty simple one to start them with. Usually the students grasp the concept that this x is a 5 from the very beginning before we even do the work. So by giving them the simpler problems to do first, it kind of builds their stamina and allows them to conquer the harder problems later. All right, so then this one is just identifying the inverse operation. So I would give them the first one. And I might even have these on cards at their desk rather than going from the flip chart. And I would have them written down. And I would ask them, okay, what operation is being performed? And they would have to discuss it in their group, and they would have to give, feedback and tell me why they think that. This is a totally new concept for them, for the variable to be right next to the number, and also just the variable in general. They kind of struggle with those letters in with their numbers. So we need to make sure that they are very clear that whenever a letter is next to a number, that is multiplication. Same thing with the rest of them. Another one that's going to give them a hard time is the division. I make my students say over and over and over that fractions are division. I kind of try to embed it in their brains so that when these things pop up, they know, oh, well, that's division. And the opposite of division is multiplication. And this one's a little bit harder to work with. You have to explain the reciprocal. So that's a little bit more difficult. I always set this one up. Let me get my pen. So for a problem like this, where I have a 4 as a denominator, I ask them, well, what would get rid of a 4 as a denominator? And they know a 4 as a numerator would get rid of that, and that would be a 1 on the bottom. And so then we're going to multiply that by the x over 4. And so these two cancel each other out. And I'm left with 1 times x, which just equals x. The more and more you do these reciprocal problems, the more and more they're going to kind of grasp the concept of what's really happening in the problem. All right, then we have practice solving the following one-step equations. I would have my class do this in partners. And before we even begin, I would have them write these on a sheet of paper, leaving themselves plenty of room to do the work. And we would go through and I would ask them, okay, for number 1, what operation do you see? Hopefully they would say that they see multiplication. And then I would ask them, okay, well, what's the inverse or the opposite of multiplication? And they would tell me division. So now they know how to solve that one. Same thing with number 2. What operation is being performed? Addition. What is the inverse or the opposite of addition? Subtraction. And I would actually have them write down what they're supposed to do so that they know when they're working with their partner what they need to do. Number 3, hopefully they would start to recognize that as division. So then they know that they have to multiply in order to get their answer. Same thing with number 4. The operation is subtraction. They need to do the inverse, which would be addition. So then they can put that they need to add here. And I think that working with a partner helps them feel a little bit more confident that they're not just left on their own. You're still going to have children that struggle. I try to pair up my kids according to their level of strength. I don't want a super high kid with a super low kid, but I'll put one of my medium kids with my low kids because usually they don't mind helping out. And then some of my lower medium with my highs. That way my groups are kind of balanced. All right, after they get done with those, we have a quick write to do. Look at the problem below, explain in full sentences how you might go about setting up an equation or model to help solve this problem. Use at least 2 or 3 vocabulary words in your explanation. Write and solve an equation to find the unknown side length. Okay, I would have to help them on this one because sometimes they're not going to see exactly what's going on. So this is important. Area equals 322 feet squared. And I would ask them, well, what's the formula for area? And hopefully they will remember that area equals length times width. And then from here, we could fill in what we know. So we know that the area is 322, and that's going to be equal to 46. And I don't know the W, so that's going to be equal to 46W. And I would actually walk them through this first part, because giving them this isn't necessarily helping them with the quick write. So now that they have this framework, they can go ahead and start the writing. I would even let them collaborate with their shoulder partner or even in their group to help them get those sentences down, possibly even giving them some sentence stems to help them get started. That way they feel more confident and more successful. After the quick write, if there's time, I would put this up on the board and just have them work on this one independently to see if they could do it. The first one is just solving, and then the second two are matching the problems to the actual models. And this is super important. They're going to see a lot of models, and we want to make sure that they're able to link the model to the problem. And this would essentially be their ticket out the door. I would collect these on their way out.